Today we actually have Svea, and she will be speaking about the Arctic tundra and some of the amazing plants that can live there. So without further ado, Svea, you can go ahead and start your presentation. You're muted.
Yep, got it. Awesome. Thank you. Hi, everyone. Thanks for joining us this evening. My name is Svea Anderson, and in 2018, I was selected as a PolarTREC educator. PolarTREC is a professional development for educators that pairs classroom teachers with research scientists in the field. And I had the most amazing adventure journey with Dr. Sidonia Brett Hart, who is an ecologist researcher out of University of Alaska Fairbanks, and she and I ventured to the Arctic. So Ria, I don't know if are you still able to see the chat?
Yes.
Okay, perfect. All right. So I have a question for everyone. I want to know what you think of when you hear the word Arctic. So if you could put that in the chat, what do you think about? We've had a lot of really good examples with the trivia, but also with the craft. But I also want to know, what do you think? Like when you hear the word Arctic, what comes to mind?
So I see cold, I see snow, glaciers.
Okay, snow, cold, glaciers, awesome.
Bears.
Yep, bears. All right. North, that's a good one, Lindsay. Awesome. So yeah, so we think about these different things. We think about it being cold. We think about it being in the north. Um, my first impression of the Arctic was that it was going to be ice and that it was going to be frozen and that it was going to just kind of be this area that there was little to no growth. And so here in the upper right-hand corner, or left hand, excuse me, this is the Arctic, right? And so in the trivia, people who got it were great. The Arctic is the region in the northernmost part of the globe, but it consists of the Arctic Ocean, some adjacent seas. We have parts of Alaska, Canada, Finland, Sweden, Greenland, Iceland, Norway, and Russia. So there's a bunch of land mass that goes around the Arctic Ocean as well. So when I think of Arctic originally, I thought, cold, right? Here's another view of it and a couple different definitions of what the Arctic and the Arctic Circle are. So you can see the Arctic Circle here in red. I don't know, Ria, can you just tell me, can you see my cursor, my arrow?
Yes, we can see that.
Okay, perfect. So this is the Arctic. And the Arctic Circle can be defined a couple different ways. So it can be defined as this imaginary line that circles the globe that marks the latitude above which the sun does not set on summer solstice and it does not rise on winter solstice. Some scientists define the Arctic as the area north of the Arctic tree line, and we'll talk about that in just a second. But I want to have you take a moment right now to kind of look at the picture. This was my first expedition with PolarTREC. I've gone to the Arctic a few times now, in 2018. And this is me at the Arctic Circle. What do you notice? Tell me. Oh, I should preface it. This is the third week in July. What do you notice? Go ahead and put it in the chat. Yeah, Julia said I'm in a t-shirt. Yeah, it's not covered in ice, right? At the Arctic Circle, we did have a few of the trees still. So in the background, you can see some trees. The further north we went, the tree line disappeared. I'm wearing sandals. I was hot. So all of my initial thoughts about what my experience in the Arctic was going to be like were completely shattered on my first day traveling north. All right. So this was my expedition map. And this is posted on the PolarTREC website. But I like this one better because this is a map of Alaska. And so this shows you exactly where I was stationed. So I joined Dr. Brett Hart at Tlik Lake Field Station, which is right here, if you can see my pointer. And to get there, I followed this road. So this road right here is very long, but I picked it up outside of Fairbanks. And just a little bit out of Fairbanks becomes the Dalton Highway. And the Dalton Highway is known as the loneliest highway in the Americas. It has very limited resources along the way. I don't know if you guys can tell or not, but it has 2 stops. Right? So there are 2 like towns along the way. I'm so sorry. I tried to get that not to show. Okay. And so I picked up the Dalton Highway. It takes between 8 to 10 hours to travel from Fairbanks up to Tlik Lake Field Station where I was. Depending on the weather, depending on the road conditions, depending on the animals that you may encounter. So it is a really bumpy road. There is a small patch of it that is paved, but for the most part of the 8 hours, you're on kind of a dirt road. The Dalton Highway is about 414 miles long, so it's pretty expansive. And I kind of wanted to see, if we start right here in Fairbanks, there are 2 stops along the way before you get to Tlik Lake. The first one I've heard pronounced 2 different ways. The first one was Living Good or Living Good. What do you guys think? Why would there be a stop on this Dalton Highway? There's nothing there. It's just wilderness. I'll put it in the chat. What do you think? Any ideas? Ooh, refueling. Thanks, Julia. Yeah, there's actually no refueling in Living Good or Living Good. In 1914, gold was discovered there. And so it was a really big, can you all see my air quotes? Big little mining town. Today it has a population of about 7. So it is pretty obsolete. There's really nothing there except a few cabins. If I wanted to get gas on my trip from Fairbanks to Tlik Lake, I would stop in Coldfoot. So knowing what I just said about Living Good or Living Good, and about it being a mining town, the history behind Coldfoot is that they said miners got up to just about this point. It's just a little bit over the Arctic Circle, and they would get cold feet because you are surrounded by millions and millions of acres of just forested land. And so the Coldfoot supposedly got its name. I can get gas in Coldfoot. There is a old station where I could spend the night it's hundreds of dollars to spend the night. There's also a little welcome station that's manned by the National Park Service during the summer, so I can go in and I can sign a book. But really, that is about it. The population was 10 people in 2010. So there's not a lot of people in these little towns. But Coldfoot is the only place to get gas between Dead Horse and Fairbanks. So everyone stops there. It also got really popular because of a show called Ice Road Truckers. And so I'm not sure what programming channel it was on, but it was very popular. I guess it has really amazing chili. And so the truckers always stop for the chili. So then going north, Tlik Lake is about right here. If I went 200 miles further, I would get to Prudhoe Bay and to Dead Horse. And the history behind the Dalton Highway was Prudhoe Bay and Dead Horse up here. And we can go into the history of the name Dead Horse too. It's not that pretty. Is that there's offshore mining or drilling up here for oil. And so all the way from Prudhoe Bay, all the way down to Valdez, runs a pipeline. So the transatlantic pipeline. So in 1974, this road was established as a support road for the pipeline. So you're just traveling along this huge pipe that goes the entire way that you go. And you can see that in this small cutout over here that we have a couple different pump stations. And these pump stations are important because one of Dr. Bret Hart's sites was at pump station number 2. So I'll talk about that one in just a second. And you can imagine dead horse. They say that you don't want to beat a dead horse because of just things. So anyways, we'll move on. And Peyton, I saw that you're here. That's awesome. Thank you for joining me. A former student, one of my favorites, is here with me. So this is remembering the details about the Arctic, right? And the sun not setting for 24 hours. This is a video that was taken. This is Tlik Lake. This is right by the field site. And I just wanted to show you this just kind of as a preface. So hopefully it's going to play. There's no sound. And psych, it never goes below. So you're surrounded by 24 hours of sunlight when you're up in Tlik between summer solstice and about September. Why is that important? Why is sunshine important? Put it in the chat. Why do you think that would be important for the tundra? Oh, that's a word I haven't used yet. So I've been talking about the Arctic, but the Arctic is also, this part is for the tundra. Yeah, Ria, for plants. Nope. As cool as it is, we won't watch it twice. So this was my field site. And from a broad lens, we can see that it is not frozen. It looks cold. This mountain range right here is called the Brooks Range. Tlik is on the north face of the Brooks Range. So in this picture, I'm looking south, which geographically always kind of threw me for a loop. I was always like, wait, what? No, south. So anytime you're looking at the Brooks, you're looking south. So you see that overall, it looks just kind of like a field, right? So, oh yeah, it's a really pretty field of green. But one of my favorite things to do was to get down on my hands and knees and to actually look at what makes it up. So in the tundra, it's made up of these individual little ecosystems called tusks. And tusks are like little mounds of raised earth. And so within each one of these little tusks is this whole little ecosystem of different types of plants. So here you see we have some, if you guys can still see my mouse down here, we have some sphagnum moss, we have some lichen, we have some grasses, but we have a huge, not huge, I shouldn't say huge, but we have more of a variety than I ever anticipated seeing in the Arctic. In this one, we have some more lichen, we have some more reindeer lichen. These, and it's not the scientific name, but I heard them referred to as mummy fingers because they look like they're coming up out of the ground, these like crazy looking plants. But you can see the grasses and the different mosses. And just really getting this perspective down on the ground, just to kind of see how each one is like fitting into the ecosystem. And because of the 24 hours of daylight, those little plants are working their hardest to do their entire life cycle. So here we have some flowering plants. They're putting out seeds. They're hoping for pollination. There are pollinators in the Arctic tundra. And so really, they are just working 24 hours a day to make sure that they're coming back next year. So they are the hardiest little survivors I have ever met. And I honestly think they're the most beautiful plants. And then this one is one of my favorites. It's a grass. This one totally reminds me of something out of the Lorax by Dr. Seuss. So again, kind of like a dandelion, where its seeds are going to kind of blow in the wind. So Dr. Bret Hart proposed this project with PolarTREC. She had been working on it for a few years before I jumped in. She had had a couple other PolarTRECers. But basically in 2011, there was an Arctic report card that concluded that the Arctic environment has undergone a fundamental shift in conditions. So the Arctic of recent years, where it became warmer and greener and less icy, is likely to be the new normal. And so one sign or a piece of evidence to support this claim is the spread of shrubs across the Arctic. And so Dr. Brett Hart's project really went through and kind of thought about, okay, well, how can we support this with more evidence, right? So her proposal is stated as this: ecosystems develop and change through interactions between living things and their physical environment. A shift in vegetation is one of the most important changes an ecosystem can experience because it can alter exchanges of energy. Remember, all of the energy starts at the sun, right? Because that gives the energy to the plants. It's water and elements such as carbon and nitrogen between the air, the plants, and the soil. In the Arctic, a widespread shift from tundra to deciduous shrub-dominated vegetation appears to be occurring. Huh. That's a mouthful, right? So, but I want to think about it. A widespread shift from tundra, which is, tundra is no trees, to a deciduous shrub-dominated vegetation. So if we think about deciduous, those are plants that lose their leaves on cycles. So we're looking to see how this changing of the ecosystem can really impact these plants, and what's going to be happening to the other plants in the ecosystem. So my project that we worked on was, she titled it Shrubs, Snow, and Nitrogen in the Arctic. It really assessed the contributions of different shrub feedbacks to carbon and nitrogen cycling, and to improve predictions of the consequences of this expansion, not only for the Arctic and regionally, but also for a global climate. So one of the things I like to think about is the Arctic as a freezer. Okay, so I was teaching 6th grade at the time of this expedition. And so I was thinking about, how do I explain this to my students? The Arctic is like a freezer. What happens if you have your freezer and you lose power? So can you guys put it in the chat? What would happen if I lost power and what would happen to my freezer? Does anybody have any ideas? Do I need to reword that? I've had a big storm. I've lost all power. My freezer is no longer getting energy it needs. What's going to happen? Yeah, Julia said everything would melt, right? Yeah, everything would eventually thaw. So I could know that I went to my freezer and maybe I peeked in and I was like, ooh, what's really in here? Like, should I eat the ice cream right now before it's totally melted? Or should I just close my freezer door and just hope for the best that my power comes back on, right? So we are experiencing right now, with the changing in the climate and the changing in the environments, somebody going to the freezer and being like, oh, look, there's ice cream. I should totally eat that. Closing the door. 5 seconds later, going back. We're speeding up the process, right? If I just went once to peek on it, or if I didn't touch it at all and was like, oh, it's going to be okay until I get, my energy back, or my power back, we would have some thawing. But right now, what's happening is there's this constant door opening and constant shift. So I hope that makes sense to everybody. The other takeaway is what's happening in the Arctic doesn't stay in the Arctic. So this is going to have a global change, this kind of dominance. So there's 2 deciduous shrubs that we're looking at right now. This one is the birch. And so the other shrub that was being studied is the willow. So we have this birch and this willow. And so if you think about down here in the lower 48, we have birch trees and we have willow trees. Remember, the Arctic, going back to that original definition, it's above the tree line. So nothing had ever really grown very tall. So these are the plants that are really taking advantage of this change. So Dr. Brett Hart proposed this study in 2015. The work didn't begin until 2017, and I was there in 2018. So what she proposed was creating 3 different sites across the Arctic that really looked at the way the plants were growing and how they were using carbon and nitrogen from the air and the soil. So what she did is she created these snow fences, right? So we called them snowdrift fences. And the purpose of these was to collect snow on one side, where I have my orange arrow, so that there's a higher snowpack on the one side of the fence during the winter months. Why do you think that would be important to have a higher snowpack? Put it in the chat. What do you think? Why would I want to have a higher snowpack on one side than the other? Does anybody have any ideas? Oh, Ashley, I can't read your whole so that it melts in the spring. I didn't see Ashley's. Yeah, Melissa, it insulates the soil. So that snow is like a blanket, right? And so we have this blanket effect. And so on the side that collects more of the snow, you have more of a blanket, more of a warming factor. Excellent. Thank you all for putting in the chat. So the snowdrift fence, the red arrow right here is the direction of the measurements. Each one was 60 meters long. So if I start here, this is 0 meters. And then I walked all the way to the end, and that would be 60 meters. The green arrow is the snowdrift side, yellow arrow is the control side. So one side was going to be able to have more snow and the other side was not. Now, I should mention this. Dr. Brett Hart had to do a ton of research before she put in these snow fences because she had to put them in a place where the wind was coming down off the north slope, right? And so you have the Brooks Range and then you have the wind patterns that are coming. And so she had to strategically place these snow fences appropriately so that they would be able to catch the most snow. And the other kind of misconception is that the tundra is actually a desert. And so there isn't the incredible snowfall that you might get in lower Alaska. It gets less precipitation up the further north. So this was my commute to work. I know, it looks rough, right? It was a good old walk to get up. So on the right-hand side here, this is Tlik. This is the field site right here. This is Tlik Lake, which is absolutely beautiful. And you can kind of see in the right side, the tussocks, right? Those little bumpy hills, the ecosystems of plants. And one of the reasons why these boardwalks scatter throughout the entire site is because the Arctic is fragile. And these little plants are hardy little survivors that are working so hard from June to maybe mid-August to really get as much energy so that they can cycle. So you don't want to jeopardize them in any way. And an imprint would kill them. So if I was to step off the boardwalk, I could do damage to the plants that are there. So these boardwalks are scattered throughout Tlik, and they make a really pretty little walk. It's really fun. So Dr. Brett Hart, this is her down in the lower corner. She had all of these quadrants and all of the snow fences. She had really strategic data that was lined up with GPS. And so when I got out there, the first kind of thing that my job was to do was to make all of these little flags. And we went out in the field and we marked where our plots were. So the year that I went, we called it the pluck. And basically what we did, is we went out and we marked these quadrants that were specific. We had a model of how big it was supposed to be. There were 4 flags on each of the corners. We went out with these huge knives. And granted, like you're out in the middle of nowhere, so there's like a safety issue, but luckily nobody was cut in the making of this project. But you go out and you basically harvest the land. So here I am out. It was a freezing day, so cold. We're in our rain gear. You can see it's raining. That was not uncommon. They have these blue gloves, right? Because we don't want to contaminate anything that we touch. We don't want to contaminate it. So we go out and we collect these little plots of earth. You can see here are 2 that have been cut. So we take everything with us, right? So we cut and then we make sure that we collect all of the plants and all of the minerals that are underneath the plant. You can see right here, there's a really thick clay-like mineral right as you hit the permafrost. And so you all did it in the trivia tonight. Permafrost is that permanently frozen earth. And so like you can take pictures of events and like be like, oh, that's beautiful. And you can take, sound recordings. The one thing I wish I could have recorded is putting my hand down in and touching the ice of permafrost. It was freezing. It was like touching an ice cube, but different because you're touching earth. And you know that this is earth that hasn't ever been touched by human hands before. It's pretty impressive. So you cut out these different quadrants of plants. You try not to damage any of the plants on the side, and you only take what's within the model or within the track, and you leave everything else behind. But then you bring it back. And so this is me in the field with a cut quadrant. So we carried them in trash bags, 1 quadrant per trash bag. It was really essential that we kept everything separated. And so I'm hiking back to the lab from the field site, and you can tell right now this was my daily wear. So I'm in bib overalls that are waterproof. I have on my waterproof boots, but I'm also in mosquito gear because with the changing climate, there is also this crazy population of the ladies of the tundra, or mosquitoes, and they swarm. It's not just one or two where you can be like, oh, I got a mosquito bite. It's billions. I'm not even exaggerating, swarming, and after a while the buzzing is just like bzz, it's crazy. So you have to wear this gear constantly to have everything covered. That was another reason for the blue gloves. It was a really good, not only were we not contaminated, but like we weren't getting mosquito bites on our hands. Oh, and the other thing is I don't have elephantitis in this picture. This is the wind. The wind is whipping so hard that it's going in through my face of my mosquito vest, and then it's going through and filling out, ballooning out my my mosquito gear. So we went back to the lab afterwards, after we had these quadrats of plants. We went back and we literally dissected them. So I would go through them. We would start the process at 9 a.m. in the morning. Sometimes we didn't get done until about 10 or 11 at night. You never left one unfinished because that could be compromised. Because we're really looking at some certain attributes of the plants to really make sure to see where that cycling is happening between carbon and nitrogen. So you can kind of see here, there's a whole bunch of bins. And so you literally put each type of plant within its own bin. So it was a tedious, I would say tedious project. You're sitting at a table all day, just kind of going through, making sure you don't miss anything. There was another group there from Arizona as well, and they were actually looking at the soil. So I was grateful that I was looking at the plants. Then you put them into an oven so that you're really just getting that biomass. And over here on the right, you just record everything in a notebook, which then gets recorded into a computer. So that's a really long process to try to see how much nitrogen and carbon cycling is happening with these plants. This is the second site. She actually had two sites at Tlik. I should say Dr. Brett Hart had two sites at Tlik. This was the third site. This is up at pump station number 2. So you can see right down here in the map inlay. And this is a totally different environment. This is further north, right? So we are really close to Prudhoe, probably about 100 miles out of Prudhoe Bay. Here is a snow fence. There were 5 of them over a mile. The same exact requirements. It was 0 to 60 meters. The same kind of structure on how they were made. But you can see Dr. Brett Hart right here. These are some huge deciduous shrubs, right? So obviously something is different in this site than what we were seeing at Tlik. And so that's all part of her research as well. And Dr. Brett Hart is about 5'9". So they're pretty impressive shrubs. And I want you to remember this picture because I have a quick story in just a second about this particular fence. So the other part of it, of the time that I was in the Arctic, is that I wanted to have a project as well. And so I measured permafrost layers to see if this was something that Dr. Brett Hart had suggested, to see if the snowdrift side versus the control side, if there was a difference in the permafrost, if the thaw level. And so I don't know if you guys could put it in the chat. Why do you think a thaw depth would be important to know? So what do you guys think? Why would it be important to know the depth of the permafrost and see how close it is to the surface? Anybody have any ideas? Yeah, right. So it could correlate to the temperature and the climate. So the warmer it's getting, the more the permafrost underneath is thawing. Perfect. So what I did is I went out into the field. Yeah, Ashley, it is like a blanket, right? That snow it's going to get it warm, except like when we get too warm and we can throw the blanket off, you can't throw like the snow blanket off the little plants, obviously. So I went out. This is me in the field again. You can see different day. It's a beautiful day outside. The weather changes really spontaneously. Mosquito netting. And I'm holding a big metal probe. And basically every 5 meters, you can see the tape. Oh, I'm pointing and you guys can't see me pointing. There's a tape measure right here. Every 5 meters, I was taking a probe. And so going down and measuring it and bringing it up and figuring out how much the permafrost had thawed. And so these were just some examples of the snowdrift side. So if we started at 0, remember the red arrow starts at 0, the base of the red arrow starts at 0, the thaw depth was 21. But as you got toward the middle of it, you know, if you got around 25, it was up to 72 centimeters, right? So that's a way vastly different than the 21. If you're going 21, you're barely getting into the earth. But if you're at 75, 72, you're really putting the probe in. And so then I also had a control side. Obviously, with any good experiment, you have two different things. And so this, again, with my control side, that's where the snow is regular. And so the results really kind of shocked me, but they didn't, right? So I went back to the classroom and Peyton, I believe this was actually your class, and I had my students graph it. And so they were like, okay, well, we have these different sides and these are the different thaw depths. And you can see, I think it was Kelly, maybe who had said earlier, it's like a blanket. The drift side did really warm up the earth and you have a way deeper thaw for the permafrost. So yeah, so it really kind of spoke to exactly that, right? Like you're going to have more of a thaw. It's going to go down deeper. There's going to be less permafrost, or it's going to be a greater melt of the permafrost on the control, or on, yeah, perfect, on the drift side where the snow was collected. Okay, I know I've been talking an awful lot. My other favorite activity, though, was collecting mosses. And if you let the moss sit overnight in water, you can take droplets out and look underneath. And so does anybody know what those are in the magnifying glass? On the magnifying? Put it in the chat if you know what that is. Yeah, it's my favorite little organism. They're tardigrades. They're called water bears. And so you can find them in the mosses. So here we have mosses being a food for reindeer, but also you have it's a habitat for other little organisms. Thanks, Julia. Okay, so here's a question for you. Why should I care about deciduous shrubs taking over the tundra? Put it in the chat. What, I mean, currently I live in DC. Why am I worried about something that's happening up there? What do you guys think? Go ahead and put it in the chat. Yeah, Julia says it messes with the ecosystem, right? Yeah, so what happens there? So really we have to think about the Arctic tundra as a whole, right? And so as a whole ecosystem, we then think about things that rely on these little plants to survive. And if some of the smaller plants are not going to survive because of these larger deciduous shrubs, what's going to be kind of the consequences of that as well? So we're going to play my favorite game. It's called Whose Scat Is That? Everyone knows that SCAT is the scientific term for. Okay, so here we go. What do you think? Yeah, Wade, you got it. All right, so put it in the chat. Whose scat is that? Oh, deer is a good guess. Reindeer. Anybody else? Ooh, an Arctic hare, good one. A bunny? Could be. All right, it's actually caribou or reindeer, okay? And they have huge herds all over the Arctic tundra. The porcupine herd has millions of individuals in it. And if you ever go on and you Google it, you can see their migrations and there's just millions of these animals just crisscrossing everywhere. They're beautiful, but they rely upon the reindeer lichen to eat. And so they basically are foraging all summer so that they can survive the harsh winter climate that becomes the Arctic. So yeah, so good job if you guys got that one. All right. Whose scat is that? Does anybody have a guess? Ooh, Melissa said a bear. Melissa, ooh, a polar bear. Interesting. An Arctic fox. Good guesses. Okay, so there, I may be wrong, but I don't believe they've ever spotted a polar bear as far south as Tlik. There might have been one, I think, now that I think about it. So the other option is a brown bear, a grizzly bear. We knew this guy was at our site, pump station number 2. He trashed one of the snow fences. We knew he was there too because he left prints, he left SCAT, just basic destruction. I actually met him face to face, and if we had a little bit more time, I would tell you. But he and I had a really good conversation, and I was like, not today, bear, not today. And luckily he made a good choice and walked away. But yeah, so you can see him right here in this picture. That's after I stopped shaking because I was like, oh, it was a bear. I came face to face with a bear. But you remember how tall those deciduous shrubs were? If Dr. Bret Hart was like, you know, how tall she is and you see the shrubs, I had no idea he was there. He had no idea I was there, and I surprised him. So pretty crazy. So yeah, so grizzly bear are out there and are common. I saw black bear and coldfoot, but I've never seen one further than that, further north. Oh wait, whose scat is that? Yes, Wade. This was how all of the scientists used the restroom. Because of the permafrost, you couldn't dig, so you couldn't dig to have septic tanks, and you couldn't use the environment the way. So really the age old like leave nothing but footprints or take nothing but photographs. We really wanted to limit our impact, and scientists in general wanted to limit their impact. So there was no running water. Well, there was running water. It was shipped in. You could take a shower like once a week for 3 minutes. I know that some people would think that's a daydream, but some other people don't. But yeah, so these were the outhouses, and they were basically just elevated pit toilets. So here's just a couple other fun pictures. These are musk oxen. They are super adorable. They're really small. They're only about 4 feet tall at their shoulders. So they're really kind of petite, but they are beautiful. They have the most beautiful fur that can be woven into scarves and hats and super warm. These are from another person who visits Tlik. His name is Seth. He's an incredible wildlife photographer. Tlik Field Station was named after this bird. It is, oh my goodness, I just lost my train of thought. I'll come back to it. There we have a red fox. And then these look like prairie dogs, but they're actually ground squirrels, but they are little chunky monkeys. They're so beautiful. All right. Okay. And then, so just a little shout out to PolarTREC because they're like my favorite professional development. PolarTREC, like I said, connects different research scientists with different educators. So this is another teacher that was up. This is actually Tlik. This is another ecological project that's going on. And then we have the famous Dr. Adamo, excuse me. And she went to study glaciers and glacial retreat. And that's actually how I know Lauren. And so that's pretty awesome. Oh, you're amazing. Okay. And then that's really it. But polar events, I know that many of you probably aren't interested in lesson plans, but the Polar Connect events are really super cool because you can go back into the library and see all of these different educators talking about their experiences with researchers. So you can go in and you can see researchers from Antarctica, you can see people from Switzerland, you can see people from Greenland. So if you're interested in polar studies, this is a really great place to learn more about different research that's happening. So thank you so much for your time and for coming this evening. I truly appreciate it. I think we have a few minutes. I totally yammered on. I totally apologize. But I think we have a few minutes right now if anyone has a question. So I'm going to go ahead and stop sharing my screen. So thank you. Thanks, Jillian. All right, Ria, do you see? Do we have any? Oh, Jillian asked, is the soil rocky? It actually, it is. It depends on where you're located. So where the plants are, you'd have smaller rocks from my experience. In Tlik Lake, you'd have smaller rocks. Sometimes you'd have a little bit larger rock. But if you go up into the outskirts of the Brooks Range, it becomes, the rocks are obviously a little bit bigger. Tons of fossils, because it used to all be underwater. So lots of aquatic fossils and ferns and things like that. Great question. Thanks, Jillian.
So, Svea, we actually have a whole page of
Oh no, and I talked so much. I totally apologize.
No, it's okay. So, I just sent you the link if you want to check out that doc. There's a ton of questions there.
Okay. I apologize. Oh, I can't get to it.
Oh, I can,
Do you want to just read me a couple?
yeah, sure.
Okay.
Okay, so the first question Robin would like to know, when you showed us the map of the Arctic Circle, she noticed it had a strange irregular shape rather than being a perfect circle, and it skirted the edge of Russia, encompassed all of Greenland, and bulged strangely into the Bering Sea. So what creates this pattern, and how come it is so uneven?
Yeah, and so that's a really great question. But you think about maps and who created maps. And so looking at the definition, they're man-made, right? And so looking at the definition of the Arctic Circle, you're going to think about what's north of the tree line, the Arctic tree line, or also what falls at a certain degree latitude. So that's a great question. Yeah, it is a little wonky, isn't it? You would think that the Arctic Circle would be just like this, but it's not.
So another question here is, do these plants that we were talking about, do they need a lot of water, or like do they get a sufficient amount?
Ooh, that is another great question. So the tundra is a desert. It gets very little precipitation. And so they do not need a lot. They're not really growing up very big, right? So they're really kind of compact. And because they're so compact, they don't need a lot, which is why they can survive in soil that could only be a few centimeters deep. They don't have very long root system. So everything they kind of need is surface level.
So Juliana would like to know, has the increase in vegetation affected the animal populations?
Yeah, so that's part of the research that's ongoing, right? And so we don't know, what are the caribou herds? Are they going to have to go into different locations? The other issue with the caribou right now is the mosquitoes. And because the mosquitoes are going through 2 to 3 to 4 life cycles during a cycle now, during a summer cycle, because it's getting warmer earlier and staying warmer later, the mosquitoes are able to breed several times, and they just harass the caribou. So I think that there's several research projects right now on food availability for them, but also like how they're being, how the population is being affected by the mosquitoes. Wade Olson, I see yours, and at some point you and I are going to have to FaceTime, and I will totally tell you about the grizzly.
So Mykola would like to know, is it possible that the ice melting could revive certain ancient species of shrubs?
Oh, that's a great question that I don't know the answer to. There is lots of microbes in the thaw and that mineral that I showed you that's really heavy and thick. But I'm not sure about previous plants. That's a great question.
Another question we have here is, how do you study carbon and nitrogen amounts in the plants after you take those samples?
Yeah, that's a great question too. So once you have those individual plant species separated, you put them into an oven and then you are just left with a biomass. And so they're in the oven for a few days and not at a high temperature, just, I don't remember the exact temperature, but you put them in for a few days and then you just have what's left. And then it goes through a process back in the lab at the University of Alaska Fairbanks that I wasn't a part of. But they go through something that kind of sorts through the particles and they see carbon versus nitrogen. Yeah, as far as I could tell, I have no idea. But once you put it through higher tech machinery, you're able to tell about the carbon and nitrogen.
And I think you mentioned this, but are there any plants that survive both in the Arctic and at lower latitudes?
So both the birch and the willow are in the, but birch and willow look different at the lower elevations because they're trees. Up in the Arctic, they are just deciduous shrubs. My other favorite little plant, which I should have pointed out in one of the pictures, is blueberries. Like they have great blueberries, which is a variant of the blueberries that we have here. But we think about blueberry bushes, but these are really small little blueberry plants.
So I think maybe some people know, but for those who don't know, could you explain what a tardigrade is?
Yeah, so a tardigrade is a microorganism that is microscopic, and they call it a water bear. And it is, you want to talk about hardy little critter, they are found pretty much everywhere. And so if you don't know what it is, I highly recommend going and looking it up. It does not look like a bear, but they're called water bears, and they're adorable. They're little squishy microscopic little guys. But they're all over, they're all in the mosses. And so you can dissect, you can just, saturate the moss and then pull out parts of the water and you can find them super easy. Yeah,
Uh,
Wade said they can live in space. They can.
yeah,
And there's still like a study out there about they spilled some. And so we don't know if they're still living on the moon or not.
I heard about that one, yeah.
Yeah.
And there's another question here. So what role does methane play in the Arctic in terms of their relationship to plants?
Yeah, so methane is found in the permafrost. And so when the permafrost is thawing and it's melting, the methane that's been trapped in this ice is being released. And so those are other studies that are happening right now as well. Even putting it into the atmosphere, like not only just the plants, but how is all of this gas release happening? What's going to happen to the rest of the population, the rest of the earth? So.
So you did mention bugs, but are there any snakes at your field site or
Oh, yay! There are not. There are no reptiles, I believe, in all of Alaska. There is a frog, one frog species that I know of, but other than that, no, which is lovely. Not lovely if you like snakes, but I don't. So I was happy to go someplace that had no snakes.
And the last question here would be, what was your favorite part of your experience in the Arctic and your least favorite?
Ooh, I've been a couple times, and so I always find different positive takeaways from each of my experiences. That's a great question. So I don't really have the polar bear. I heard the polar bear. It was not a polar bear. It was a grizzly. Meeting the grizzly in 2019 was definitely my best story of the year. And probably the hardest thing is going to sound very vain, but only getting to shower like once a week, and you could only do laundry every other week. Ooh, I, I, it was hard to get used to. But that sounds vain, but modern conveniences.
Okay, so that was our last question. Thank you so much.
Thank you.
It was really interesting. And thank you to all of our viewers for tuning in and listening and watching. That was a really great talk. And so don't forget to join us next time on November 18th at 6 p.m. We will have Dr. Sally Werner, who is an assistant professor of climate science and physics at Brandeis University. And Dr. Werner will be talking all about how the ocean moves and mixes and why the turbulence is important. So once again, that event will be our next one on November 18th. And again, it's about ocean turbulence. So don't forget to join us that day. And thank you again so much, Svea, and thank you to everyone, and have a good night.